Okay, so first things first, we're in the Milky Way galaxy, right?
Right, this massive flat disk of stars, just absolutely full of them.
And our solar system is like a little tiny speck in this giant disk,
Yeah.
but it's still pretty incredible when you think about it.
Oh, absolutely. And you know what's fascinating? Our solar system sits pretty close to the plane of this disk. So when you look up at the Milky Way at night,
Oh yeah, that band of stars stretching across the sky.
exactly, that's us looking at the galaxy edge on from our little spot inside.
I never thought of it that way. That's so cool. Okay, so we've got this address in the Milky Way, but now I'm thinking about the crazy range of scales even within our solar system.
So yeah, from tiny dust grains to giant planets.
The textbook mentioned osmium, the densest material on Earth.
Right, heavy stuff.
But compared to a neutron star, it's practically nothing.
Oh yeah, neutron stars are insane. Imagine squeezing Mount Everest into a teaspoon. That's the kind of density we're talking.
That's wild. And then on the other end, you've got the near emptiness of space.
Mind-boggling, isn't it? The vastness of it all.
It really is. Okay, so we've got these crazy extremes, but let's talk about the heart of it all, the sun.
Our very own star.
I always thought of it as just this big ball of fire.
Well, it's definitely fiery, but it's so much more complex than that. The sun's a powerhouse, a giant fusion reactor.
Right. And what about those sunspots? I always found those fascinating.
Yeah, sunspots. They're actually cooler regions on the sun's surface caused by magnetic activity.
So they look darker because they're cooler than the surrounding areas.
Exactly. And here's the thing. They're not just static. They come and go in cycles.
Oh, yeah. I remember reading about those cycles. They last about 11 years, right?
That's right. And these cycles are linked to all sorts of solar phenomena, like solar flares, which are sudden bursts of energy from the sun.
Those sound intense.
They can actually reach Earth and disrupt our technology. Sometimes imagine a power outage, but on a global scale.
Yikes. Okay, so understanding the sun is pretty important for us down here.
Absolutely. What's important to remember is the sun's influence goes way beyond what we see, the solar wind, for example.
That constant stream of charged particles flowing out from the sun.
Right. It shapes the environment of the entire solar system, and it's what creates those beautiful auroras we see near Earth's poles.
The northern lights. Okay, so we've talked about our place in the galaxy and the sun. Now let's zoom in on the planets. The textbook divides them into two groups,
The rocky inner planets and the gas giants further out.
like a clear dividing line in space.
It's all about how our solar system formed. The inner planets formed closer to the sun, where it was too hot for lighter elements like ices to survive.
So that's why they're mostly made of rock and metal. Mercury, Venus, Earth, and Mars.
Exactly, each one with its own unique story.
Speaking of unique stories, Mercury, the smallest planet, has a day that's longer than its year. How does that even work?
It's all because of its strange rotation and its orbit around the sun.
So a day on Mercury's sunrise to sunrise is actually longer than the time it takes to go all the way around the sun.
Precisely a cosmic oddity.
And then there's Venus, similar in size to Earth, but definitely not a place you'd want to visit.
The ultimate hot box with a runaway greenhouse effect. It's even hotter than Mercury.
That thick atmosphere trapping all that heat.
A stark reminder about the delicate balance of our own planet's atmosphere.
It really makes you appreciate Earth's Goldilocks zone. Just the right conditions for liquid water and life as we know it.
We are incredibly lucky to be here.
And then there's Mars, the planet that holds this allure of maybe once having been habitable.
It's like a planetary mystery. We see evidence of ancient rivers, lake basins, maybe even a vast ocean.
But now it's dry and cold. What happened?
That's the big question scientists are still trying to piece together the puzzle. The leading theory is that Mars lost a lot of its atmosphere over time.
Leading to a drop in pressure and temperature, making liquid water impossible.
A planet-wide case of cosmic climate change.
It's almost tragic, but maybe there's still life hiding somewhere beneath the surface.
It's a possibility that keeps scientists searching. Imagine discovering even microbial life on Mars.
It would be a game changer. Okay, so we've explored these rocky survivors, the inner planets. Now let's venture out to the gas giants.
The realm of swirling storms, colossal rings, and fascinating moons.
Jupiter first, the king of the planets.
Absolutely massive. It could swallow all the other planets and still have room for dessert.
And that great red spot, a storm larger than Earth raging for centuries. What keeps a storm going for that long?
Jupiter's atmosphere is a wild place, driven by intense heat and rapid rotation. It's like a giant cauldron of swirling gases.
And the great red spot is like a never-ending hurricane.
a testament to the sheer power of Jupiter's weather.
And then there are Jupiter's moons, a whole entourage of them.
Over 79 known moons, and some of them are as big as planets themselves.
Like Io, the most volcanically active body in the solar system.
It's constantly erupting with molten lava and sulfurous plumes, a sight you wouldn't want to miss, well, from a safe distance, of course.
And then there's Europa, the ice moon with a hidden ocean.
Thought to contain more water than all the oceans on Earth combined and potentially harboring life.
It's like a cosmic lottery ticket. If we find life on Europa, it changes everything.
It would redefine our place in the universe.
Okay, my mind is officially blown. We've got giant storms, volcanic moons, hidden oceans, and we haven't even gotten to Saturn, Uranus, and Neptune yet.
Don't worry, we'll get there. They each have their own incredible stories to tell.
I can't wait. Let's keep exploring this solar system of ours. All right, ready for more solar system adventures? Where are we headed next?
Let's stick with the gas giants. For now, we were just starting to uncover the mysteries of Jupiter and its moons.
Yes, Jupiter, the king of planets with its swirling storms and that massive great red spot.
A planet that definitely captures the imagination.
It really does. What could possibly fuel a storm like that for centuries?
It's a combination of factors. Jupiter's internal heat, its rapid rotation, and the complex interactions of its atmospheric layers.
So it's like a giant weather machine constantly churning and generating energy.
Exactly, a force of nature unlike anything we see here on Earth.
And then there are those moons we were talking about, Io and Europa.
Ah, yes. Io, a world of fire and brimstone, constantly erupting with molten lava and sulfurous plumes.
The most volcanically active body in the solar system. It's hard to even imagine.
And then you have Europa, serene and icy, but possibly hiding a vast, warm ocean beneath its surface.
A hidden world with the potential for life? It's incredible.
One of the most intriguing places in our solar system, for sure.
If we find life on Europa, it would change everything?
Absolutely, it would redefine our understanding of life itself.
Okay, so we've got Io, the fiery moon, and Europa, the icy moon, with its hidden ocean. But Jupiter has so many other moons. Are any of them as fascinating?
Oh, absolutely. Ganymede, for example, is the largest moon in our solar system, even bigger than the planet Mercury.
Wow, a moon bigger than a planet? That's wild.
It even has its own magnetic field, which is pretty unusual for a moon.
So it's like a mini planet in its own right, and it might have a subsurface ocean too.
Possibly even larger than Europa's ocean, and there's also evidence of a thin atmosphere composed mostly of oxygen.
Okay. I'm starting to think we could spend this whole deep dive just talking about Jupiter and its moons.
There's certainly enough to talk about, but we do have other gas giants to explore.
Right, Saturn, the ringed planet. It's been my favorite since I was a kid.
Those rings are definitely mesmerizing. They're made up of countless icy particles ranging in size from tiny grains of dust to chunks as big as houses.
And they're incredibly thin too, right?
If you scaled Saturn's rings down to the size of a football field, they would be thinner than a sheet of paper.
It's hard to wrap my head around that it's like a cosmic ballet with all those icy particles swirling around Saturn.
And the rings are constantly changing too, with particles colliding and creating ripples and waves.
So it's not just a static ring system, it's dynamic and ever-evolving.
Exactly, a truly breathtaking spectacle.
Okay, so we've got these incredible rings, but what about Saturn's moons? I remember reading about Titan, the one with a thick atmosphere.
Titan is truly unique. It's the only moon in our solar system with a dense atmosphere, and it has lakes and rivers on its surface.
But instead of water, it's liquid methane, right?
That's right, liquid methane and other hydrocarbons. It's like a primordial Earth frozen in time.
So what would it be like to land on Titan?
Well, you'd need a very good spacesuit, for one thing. It's incredibly cold on Titan, about knockin' 179 degrees Celsius.
That's chilly.
And the atmosphere is mostly nitrogen, but it's so dense that the surface pressure is similar to Earth's.
So you could walk around on Titan without being crushed by the atmospheric pressure.
Exactly. But you'd still need that spacesuit to protect you from the cold and the lack of breathable oxygen.
It sounds like a science fiction writer's dream.
It really does. And Titan is a place that could hold clues to the origins of life itself.
Because of those organic molecules in its atmosphere?
Exactly. It's like a laboratory for studying prebiotic chemistry.
Okay, so we've covered Jupiter and Saturn, these massive gas giants with their incredible storms, rings, and moons.
What about the other two gas giants, Uranus and Neptune? They're a bit more understated, but still fascinating.
Yeah, I'm curious what makes them stand out.
Well, Uranus is tilted on its side, so it rotates almost perpendicular to its orbit around the sun.
A sideways planet, what could cause that?
Scientists believe that Uranus was struck by a massive object early in its history, knocking it off kilter.
So it's like a cosmic accident that left Uranus rolling along its orbital path.
Exactly, and because of this tilt, Uranus has extreme seasons with each pole experiencing 42 years of continuous sunlight followed by 42 years of darkness.
That's incredible. 42 years of daylight followed by 42 years of night. I can't even imagine.
It makes Earth's seasons seem pretty tame in comparison.
It really does. What about Neptune? What's its claim to fame?
Neptune is known for its incredibly strong winds, the fastest in our solar system.
Wow, how fast are we talking?
They can reach speeds of over 2,000 kilometers per hour, faster than the speed of sound on Earth.
That's insane. Those winds must create some pretty wild weather.
It's a planet of extremes, for sure.
So we've explored the four gas giants, Jupiter, Saturn, Uranus, and Neptune, each one unique and awe-inspiring.
And they're just a part of the incredible diversity of our solar system. We haven't even touched on the smaller icy worlds beyond Neptune.
Like Pluto, Eris make those dwarf planets and all the other icy bodies in the Kuiper Belt and beyond.
It's a whole other realm waiting to be explored.
It's amazing to think that our solar system extends so far out into space, from the sun to the gas giants and beyond.
It's a vast and complex place full of wonders and mysteries just waiting to be uncovered. Right, so we're heading even further out now, beyond the familiar planets to the outer reaches of our solar system.
Into the realm of icy worlds and dwarf planets, right? It's like the Wild West of our cosmic neighborhood.
Exactly, we're going beyond Neptune into the Kuiper Belt, a vast region of icy bodies frozen in time since the solar system's early days.
Okay, so picture a giant donut of icy objects extending outwards from Neptune's orbit. That's the Kuiper Belt.
And it's home to dwarf planets, comets, and countless smaller icy bodies.
Including Pluto, right? The one-time ninth planet that got demoted, but it's still hanging out in the Kuiper Belt.
It certainly is, and it's not alone out there. The Kuiper Belt is a bustling neighborhood full of fascinating objects.
It was the discovery of other large Kuiper Belt objects like Eris and Makemake that led to Pluto's reclassification as a dwarf planet.
That's right. Those discoveries really shook things up in the planetary world.
It's like a cosmic game of musical chairs with Pluto losing its seat. But I imagine the Kuiper Belt is a pretty chaotic place with all those icy bodies zipping around.
It's definitely a dynamic region with objects constantly colliding and interacting gravitationally.
Are there a lot of collisions out there?
More than you might think, and sometimes these interactions can fling objects inwards towards the sun.
And those become comets.
Exactly, those cosmic snowballs with their spectacular tails. They're like visitors from the outer solar system.
I remember seeing Halley's Comet when I was a kid. It was such an amazing sight.
Comets are fascinating. They're like time capsules from the early solar system, preserving material that was present billions of years ago.
So by studying comets, we can learn about the conditions that existed when our solar system was forming.
Precisely, they offer a glimpse into the past, a window into the solar system's ancient history.
Okay, so the Kuiper Belt is this vast, dynamic, and mysterious region, but what lies beyond it?
Beyond the Kuiper Belt, we enter the realm of the Oort cloud, an even more immense spherical cloud of icy bodies.
And it extends incredibly far out, right?
Oh yes, the Oort cloud is thought to extend out as far as 100,000 astronomical units from the sun.
100,000 astronomical units. It's mind-bogglingly far away. We're talking trillions of kilometers.
To put it into perspective, if the sun were the size of a basketball, the Oort cloud would extend out almost to the next town.
That's incredible. It's hard to even fathom something that vast. So the Oort cloud is this distant icy shell surrounding our entire solar system. How did it form?
That's a great question, and it's still a subject of ongoing research, but the leading theory is that the Oort cloud formed from the leftover debris of planet formation.
So early in the solar system's history, all those icy bits and pieces that didn't become part of planets got flung outwards.
Exactly, and they ended up forming this vast reservoir of comets in the distant reaches of the solar system.
It's like the cosmic junk drawer of our solar system, all those leftover remnants of the planet-building process.
A treasure trove of information about the solar system's early days.
So we've journeyed from the sun to the planets and their moons, and now we've reached the outer limits of the Oort cloud. It's been an incredible journey.
It really has, and we've only just scratched the surface. There's still so much more to discover about our solar system.
With every new discovery, we uncover more mysteries and wonders. It's a reminder that we're part of something much larger than ourselves.